Area of a two-dimensional figure, and how is area calculated? Well, let's kind of take a look and see how everything is based. When we're looking at two-dimensional figures, we're looking at flat figures. So here we have a quadrilateral. We know that a quadrilateral, the formula for the area is finding the length times the width. So let's use that idea and find this. So the area of this quadrilateral is 6 inches times 3 inches. Multiply that together, 6 times 3, we'll get 18. Now the type area, because it's inches times inches, that means we need inches squared. You might want to think about in terms of x's, right? Because if you had x times x, that would be x squared. Just like whatever variable we're dealing with here, we're dealing with inches, it would be inches squared. And we can show that by putting in squares in here to see where that also comes from. Here is 3 squares by 6 squares, and you can see that we're going to get 18 little square boxes in there, and that's where that squared part comes in. So now let's talk about the area of a triangle. Well, area of a triangle, but I'm looking at a rectangle. You have to remember that a rectangle is made up of 2 triangles. So our formula for finding the area of a triangle is 1/2 the length times the width, or other words we've used before, base times height. And basically what we're doing to that is dividing it by 2. That's going to get us the area. So either of these work and gets us the idea behind the area of a triangle. So if we're looking at this triangle here, 3 inches by 6 inches, we would say our area of our triangle is equal to 6 inches times the height, which is 3 inches, and we're going to divide that by 2. So our area of our triangle, 6 times 3 is equal to 18. 18 divided by 2 is 9. So we have 9 inches squared. Let's take a look at a composite figure. And this may look like a crayon, a pen, a rocket on its side, a house laying down. So we've got some things to look at. But we notice that we're looking at the area of a rectangle and an area of a triangle. All we have to do is add those 2 areas together and remind ourselves that area is the inside measurement. We add those 2 areas together and we're going to get the area of our strange figure. So once again, let's figure that out. Take the area of the rectangle, which would be length, base times height, or length times width, 6 inches times 3 inches. And that area of that rectangle then would become 18 inches squared. If we do the same thing for the triangle, we would say 3 inches times 2 inches and divide that by 2. And find out the area of the triangle, which would be 3 times 2 is 6, divided by 2 is 3 inches squared. And what we would do is take both of these, excuse my bad squares there, but we would take both of those and add them together. So to find the area of this strange looking object, we would say 18 plus 3, which is 21 inches squared. Now, you'll notice that I'm basing everything on the formula for the area of a rectangle or a quadrilateral. Well, that is true for all shapes, and I'm going to give you like a crude representation of how that applies to a circle. So here we're going to find the area of a circle. I'm going to color the inside of the circle black, but I want to color half of it or a hemisphere of it in blue. So you can see how this all comes about to find the formula for the area of a circle. I'm going to draw some triangles in those halves. And what do I mean by that? Let me pull this to the front. What I'm saying is that if I were to draw into each one of these, if I was to draw a triangle into each one of these, I could draw a multitude of triangles, basically looking like this. I'd have blue triangles and I'd have black triangles. I could take these black triangles and turn them and get them to line up so that I make another shape. And that's the shape of a rectangle. We know a rectangle, we would do length times width. So we're going to kind of use our colors to help us to decide what's the width of this and what's the length of this. And look at the colors. We know that's a triangle. So that triangle is only going to give us the radius from one point out. So here we have the radius. Here we have half of the circle, or half of the circumference. So what we want to do then is to remind ourselves what circumference is. Circumference is pi times diameter. So if I only want half the circumference, in other words, I want half of the diameter, easier to take half of the diameter than half of pi, taking half of that, half of a diameter would be a radius. So basically now I have pi times r is going to get me my length. My width is r. So radius times radius will get me the formula pi radius squared. Now what I'm going to do is solve one problem only. And here I have a circle that's 6 millimeters on the diameter. I know that I need a radius in order to solve the problem. So I know the measurement of the radius is 3 millimeters. When I go to find my area of the circle, I'll take pi and I'll multiply it times 3 millimeters times 3 millimeters. Now you'll notice I have here in red, exact measurement includes pi in the answer. So we're going to do that. We're going to say 3 times 3 is 9 and pi, and that's going to be millimeters squared. That's going to be our exact measurement because pi goes on forever and ever. Now if I wanted to find the approximate measurement of the circle, I would use 3.14 for that. So let me grab a calculator here and let me do 3.14 times 9, and I get 28.26 millimeters squared. And that's an approximate measurement because we know pi is bigger than 3.14. I may have you and ask you to round to the nearest tenth. If that was so, that would be 28.3 millimeters squared. We have to remember about rounding. Remember, if the number that you're going to look at next to it, if it's 5 or more, you're going to round up. If it's 4 or less, you're going to leave it alone. Hopefully that's a good reminder right now of what we've gone through about basic shapes and their ways of finding their area.